Simple harmonic motion is motion that is rotational in some way and periodic. So we reach a high point and a low point, and the pattern is, there's a pattern. This is a classic example where you have a weight on a spring, and if you displace it from its equilibrium and then let it go, it will bounce down and then back up, and it just kind of bounce back and forth. And that's an example of simple harmonic motion. Simple harmonic motion can be modeled with these two basic functions, our cosine function and our sine function, where A is, the absolute value of A is our amplitude or maximum displacement from the equilibrium. B is, we still have the period of 2 pi over the absolute value of B, but we have this other thing that we call the frequency. That's B over 2 pi. Note that this is just the reciprocal of the period. And what frequency is a measurement of the number of cycles that are completed in 1 unit of time. So it'd be something like, 3 cycles per second or something like that. These two equations can actually, we can actually extend them a little bit by doing some phase shift with the t, or by doing a vertical shift if your equilibrium is not at 0 and you want to measure height, for example, height maybe above the ground. Then your equilibrium might be a different number, and so you'd have plus some number out here. The way we determine between whether we're going to use cosine or sine is simply where our initial position is. If we start at our equilibrium, it's going to be easiest to use the sine function. And if we start at a peak or dip or maximum or minimum, then we're going to use the cosine function.